In the previous lecture, we saw that matter is made up of atoms, and atoms are made up of protons and electrons because particles with different charge attract each other, and particles with the same charge repel each other. There are interesting dynamics going on inside of matter. Depending on the atomic molecular structure of solids, this can be a conductor of electricity if some charges can move freely in them. These would be the metals that are good conductors of electricity and why cables are made of metals. If the structure is such that electrons can't move and are trapped, then we have an insulator, such as plastic, paper, glass. Nevertheless, even though charges are trapped inside of insulators, they have some room for small displacements around their position. That is what happened to the strips of paper in the previous lecture. There, the charges redistribute and the positive charges displace towards the negative rods while the negative charges displace away from the rod. This can also happen if you put the rod near the conductor. Consider you charge positively a rod and put it near but without touching a metallic sphere. Then electrons will freely move near the rod. Consider now two spheres in contact and charge a rod to get close to only one of the spheres. Electrons from both spheres will move towards the rod. Remember that the spheres are in contact and the charges are free to move in the metal. If you then separate the spheres, you will have positive charges in one sphere and negative charges in the other sphere. You have charged the spheres by induction. In this simple electrometer device that can be used to measure charge, because these foils are made of metal, charges are free to move and they can move from one foil to another if they are in contact. Let me rub this rod and put it near the ball. The ball is in contact with the foils. I am not going to touch the ball, but I am going to put my magic wand near it so that my negative rod is attracting the positive charges and leaving the negative ones far from the wand, that is, in the foils. Then both foils are negatively charged, that is why they repel each other. In the next lecture, we will start to quantify these effects. May science be with you.